record this one. Okay. So we have these types of problems. And if you remember, and I'll stop sharing and I'll share again, Ignithium. And by the way, if you want to know, I always get through the Cornell homework before the end of the semester. The last 3 topics, I don't know about. So if you guys are working ahead, and we covered cost curves really quickly by way of review, you can go ahead and you can get started on the cost curves and the competition stuff, or not the competition, sorry, the monopoly stuff, because we're going to do that next, and then we'll do the cartels on the Cornell. But right now we're still up here on choice basics, and then we have these last 2 questions. And what makes these last 2 questions kind of a challenge is that if you remember from our diagram before, we have this new point, XS. I highlighted there. So let's see. Sonika, are you with me?
Yeah.
Yeah. So we have to find XS, and if we do that, then we're pretty good. Okay.
Mm-hmm.
So let's focus on that, because this is the thing that ends up being different. So I'll stop share, and I'll go back to the whiteboard. Okay. So, and let me, just so we have a good example to work with, I'll copy this stuff here. And this actually looks like it's a really nice example, because all of the numbers look pretty good. Okay. And I'll move stuff around a little bit. Okay. Okay. So, all right. As I explained last time, and you know, hopefully y'all go back and look carefully at the last lecture. But basically, what we end up with, and in this case, you'll note the price of tacos is going from 7 to 9. So this is a case where we have a price change that's a price increase. And so initially, let's see. Okay, you with me, Sonika?
Yeah.
So initially, we're going to have a budget like this. Remember, tacos is on the x-axis. And when tacos get more expensive, it's going to rotate in like that. Does that make sense?
Mm-hmm.
Right? Okay. And so I'm going to draw these 2. The orange one can be the initial budget.
Mm-hmm.
And let me see, that it's always hard for me to draw the indifference curves here. But this will be our first tangency. And then this will be our second tangency. So we have these two optimal consumption bundles, and I'll draw them bigger than they got to be, but there's one, and then I'll do what are at these 2 points of tangency. Does that look good to you, Sonica?
Yeah.
And then I'll go back and say, okay, there's going to be, what we're doing is it's the price of X that's changing. So we're curious about the impact on the quantity of X. This is where we get our information, remember, for our demand curve. We have different prices for X and different quantities of X. So this I would call our X0 star, our optimal amount of X initially. And this one I would call our X1 star. Okay.
Mm-hmm.
And see if this is gonna, I want to select X0, not, anyway, it's close enough.
It's because you put them in the same text box, I think.
No, actually they're in different text box. I can show you that. I can, boom. See, I don't know if you could tell, but I closed it.
Yeah, I can tell.
So there. Okay. So the important thing is that, and this is actually opposite of the case that we had before. Like I said, sometimes Ignitium will give us price increases and sometimes they'll give us price decreases. This one was a price decrease. So I'm gonna also label this one is our initial, I'll call it U0 star, optimal level of utility. And this is our U1 star, okay? So one of the things that's pretty important is that if you want to understand how to solve the income and substitution effect decomposition, you have to keep track of, where were we, what was our initial optimal consumption bundle, which in this case is the red dot. And then the pink dot is our optimal consumption bundle after the price change, right? So you got to keep track of this before and after. You with me, Tanika?
Mm-hmm.
And then, right, to find XS, we're going to take the new budget, right, and find out where it's tangent to the original indifference curve.
So have to take the new budget line, which is,
yeah.
Okay, and
so and I'll just put it up here. XS is determined by one. I'll put original. You can see the 0 maybe it stands for original, right? Difference curve and new budget line. Okay.
Mm-hmm.
And I should say more specifically where 1 and 2 are tangent.
For 1 and 2 are tangent. Are you talking about, okay, so the original one and the new budget line. Okay.
Yeah. And I'm gonna make this a purple dot. Well, it was supposed to be a purple dot. So okay. You see what I mean?
Yeah.
And so then I go back to here. And that's going to be where our XS is. Okay. And then remember, we find the substitution effect in any case that we have where we have two dots on the same indifference curve. So the red and the purple, that's our substitution effect between X0 and XS. And then between XS and X1 is an income effect. And we consider them in sequence. So what we, and really what we're trying to get at, so I'm going to focus on how to solve this so we can kind of move on through the material. Yeah. But I do want to say for a minute that the point of this exercise is to try to answer the question, if we were to hold the consumer's real income constant, and notice that we're using their original utility level as a proxy of their real income. And the reason for that is because we're appealing to this idea that real income is a measure of purchasing power. And also it's a measure of, more importantly, like the standard of living. And so what I'm saying is, if the consumer moves from the red consumption bundle to the purple consumption bundle, what do I know? Well, what's their level of utility, Sonica, at the red one? It's U0 star.
U0 star.
And what's their level of utility at the purple one?
Would it be
It's also U0 star. Because see, they're
yeah, because they're at the same line. Yeah.
They're both on the same indifference curve. So by definition, they have to give the same level of utility, and the consumer is indifferent between them.
Yeah.
Right. So if you're a consumer and I say, hey, I'm going to move you from the red bundle to the purple bundle, what you're going to say is, okay, like, I don't care, because remember, the way to think about the indifference curve, if you have trouble with the idea of indifferent being like, I'm indifferent between the two options, just think of it as being an I don't care curve. Yeah. I don't care if you give me the red one or the purple one, because I'm getting the same level of utility, right? You know, I don't care if I have 3 pieces of pizza and 4 beers, or I have 4 pieces of pizza and 3 beers. I'm just as well off. So my standard of living isn't affected. My utility isn't affected. So that's why utility becomes a way of measuring real income, even though it's not related to the consumer's budget. Do you see what I'm saying?
Yeah, I understand. Indifference essentially means that when you're given 2 pairs, you're indifferent from either of them. So the indifference curve means wherever you place me on that curve, I don't really care.
Yeah, I don't really care because I'm just as well off. So, but the thing that we know that's different between the red dot and the purple dot, right, is the red dot is what the consumer chooses under their original budget with the original prices that they're facing for the 2 goods. In our example, the red dot is what the consumer chooses when they have a a
And then-
nominal income of 152, and they face a price of tacos of 7 tacos
Mhm.
and 9 for tequila, right?
Yeah.
But notice that with this new, and this is really a fictitious budget, right? We don't know what, and you can actually calculate this, and I did it one year for students who are curious, because if you're a little bit facile with algebra, then you can use what you guys might have seen before. They call it the point. We've talked about 3 different ways of representing linear equations. One of them is the general form, which is just the, you know, ax plus by is equal to c. And then the one that you guys are more familiar with, that everybody does for graphing, is a slope-intercept form, y is equal to mx plus b. But there's also another one that is usually taught like in 8th or 9th grade algebra, which is called the point slope form, which means if you have a point on a line and you have the slope of that line, then you can, you have all the information you need to find the other like general form and slope intercept form. So if you find the slope intercept form using this point and the slope of this line, which you know the slope because the slope is coming from the new prices, right? And remember, the prices determine the slope of our budget. So
is it essentially the tangent line is the tangencies? Like I remember from the previous problems, we were doing tangency and budget.
yeah.
So would one of those slopes be the tangent and the other slope would be the budget?
Yeah, exactly.
About?
But in this case, right? So the new budget line, which I'll put it back in its original position, the new budget line, remember, and I will say something that maybe will be helpful in terms of making the connection, but the tangency condition, what it's talking about, right, is the tangency is where the slope of the indifference curve is equal to the slope of the budget.
Yeah.
Right. And we have these general terms for the slope of the indifference curve, which remember is the MRS, the marginal rate of substitution. And the general term for the slope of the budget is our PX over PY. Okay. And remember, technically, it's minus PX over PY for the slope of the budget. But because we end up, when we go from the slope of the indifference curve to the marginal rate of substitution, remember the marginal rate of substitution technically is the absolute value of the slope of the indifference curve. So I could put like this, absolute value, maybe that'll help. And when we take absolute value of one side, we'll take the absolute value of the other side too. So both of these negative quantities become positive.
Yeah.
And then we can get rid of the negative sign. And this is exactly, this is the true. Marginal rate of substitution is equal to the price ratio. Okay. But notice here, the new budget, the yellow budget, well, we have this information, right? Well, I can write, you know, the original budget here. So original budget is going to be 152 is equal, well, the price of X, we said 7X times the amount of X plus 9Y, right?
Mm-hmm.
And the new budget is equal to 152. And we said the price of tacos increase 9X plus 9Y. You follow?
Yeah.
Right? But notice that once so we know, for example, here on the y-axis for both of these in our example, and I'll let you tell me what is the vertical intercept.
Professor, one quick question.
Yeah.
I'm actually kind of confused on why is x1 further inside, like to the left of the graph than x0, because I remember you were mentioning before that, oh, now we're dealing with a decrease in one of the prices.
An increase, actually.
Yeah, so that's why I was confused, because you mentioned decrease before, so I was like,
oh, well, maybe it's because I told you sometimes, you know, I didn't mean this example. Sometimes Ignithium will give you a price increase, and sometimes it'll give you a price decrease. If you look at the recorded lecture from last time, we did an example with a price increase.
Yeah.
I mean, a price decrease, and this time we're doing a price increase.
So then my question is still that, why does that x1 go further into the graph than towards the right of?
You mean like here?
Yeah, then to the right of x0.
Okay, well, I'll just ask you. This is going to be it. This isn't the whole answer, but this is the, and who am I talking to right now? Sonica?
Mm-hmm.
Is that who's talking? Sonica?
Yeah.
Okay, Sonica, if tacos were $7 a piece, would you buy more or less than if they were 9?
I would buy more at 7.
Yeah. So
Okay.
less.
Yeah, I get it now.
More, less. And we could actually find out what x0 and x1 are, and we're going to do that in a minute, but we really want to focus on xs.
Yeah.
The point is that, okay, so now I'll ask what I was asking before. So, and anybody can chime in on this in the chat or anything else. If anybody wants to, you can put it in the chat. What is the vertical intercept here? I need a number.
Would it be 16.88 or 89?
Tell me how you calculated that.
So I rearranged it so it's negative 9y equals 7x minus 152. And then I basically made it so that y equals mx plus b form.
Yep.
When you divide by y, you'd get, like, I used the original budget one, so you'd get 9 over 7x minus 152 divided by, negative 152 divided by 9. So that would be 16.89.
Yeah, and notice, right? And everything you did algebra is perfect. It's no big deal, right? But remember what and the algebra is the same either way, but remember what this represents is if the consumer was to spend all of their budget on only purchasing, in this case, tequila, what's the maximum amount they could purchase, right? It's when they purchase 0 tacos and only tequila with all of their budgets. So yeah, that would be what you said. It's going to be the whole budget, 152 divided by 9, right?
Yeah.
So the point is that with the old budget and the new budget, like you found out, this ends up being the vertical intercept when you use the slope intercept form of the equation, right?
Mm-hmm.
Right? But what about now?
Yeah, that would be,
You don't know.
yeah, you wouldn't know.
Yeah, you don't know. Not unless you say, oh, well, once I find this point, which I'm going to show you how to find first. Once you find XS, and there is obviously, because it's a budget constraint, I'm going to leave this off, but obviously there's a YS too,
Mm-hmm.
right? But once you find XS and YS, once you find this point and you know the slope of the line, then you can use what I call the point slope form of the equation to actually figure out what the whole equation is, meaning that you could also find out the vertical intercept up here. You see what I mean?
Yeah, it has to be like somewhere far off from the
Well,
original.
yeah, I mean, just the way that our graph is, right?
Yeah.
But yeah, or our illustration. But anyway, we'll do that later, and let me just, or we'll leave that for another time. Make sure I'm getting my slopes right again. Okay, so that's close enough for purposes of illustration. But what do we know about this point? That's the difficult task before us, right? Well, we know, right, that it actually occurs at a point of tangency 2, right?
Yeah.
And so it's going to satisfy this sort of equation too. But remember that if we're being careful, right, what's changed is we have our price of X changing from the original price of X, which was 7, to the new price of X, which is 9. So actually, to find these two, and I'll the red and the pink one, right? We need to use our MRS, and we need to recognize that the red one is based on the original prices, right? And the pink one's based on the new prices.
Yeah.
So the new prices determine the slope of the yellow budget line, and the old prices determine the slope of the orange budget line.
Mm-hmm.
So now I know, oh, well, this is a point of tangency, right, for the original level of utility, but we're using the marginal rate of substitution and the new prices. So I can put all that together and end up with the following. Okay. To find XS, I need a tangency condition. And again, it's going to be MRS is equal to PX. And I'll put PX1, meaning the new price of X and the new price of Y, but the new price of Y is the price of Y didn't change. And the second one is real income constant. Okay. And for us, remember, we're going to end up with a U0 star. That's going to be a number. And then we just use the Cobb-Douglas utility function formula. So it's going to be, and I'll I guess, just be really explicit. X, but in this case, right, it's going to be XS raised to the A times YS raised to the B. Okay.
Mm-hmm.
And what you're going to see in a minute is this is where all of the information comes together. So these two equations will define XS for us. So we're going to ultimately solve for XS. These two equations will define XS for us. And this is where we bring everything together, because if you remember, and I'll show you just really quickly, I'll stop sharing this and I'll share the Ignithium screen, right? As we go through all of these problems, we're going to find out not only our X0 and our X1 star, our optimal consumption bundles, our quantities, but we're also going to find out the level of utility both before and after the price change. So those are numbers we can substitute in there.
Mm-hmm.
Remember, okay, so this one says how much utility before the price change, 10.25, right?
Yeah.
How much utility after the price change? 9.63. Okay. So now, so you all can remember. So this is, and I'll copy it. So this is before the price change.
So this would be before it turned to $9 per taco.
Yeah. Right. Okay. So now I can go back here and hopefully I can get everything arranged. So now we know that this is actually a number, 10.25, right? And so now I can go back here and I can say, oh, okay. So my tangency condition 1 is going to end up taking the form. So we know it's A, Y, S over B, XS, right? We said it's alpha Y over beta X, right? Is equal to, and our PX1 is our new price of X. We know the price of tacos goes to 9 and the price of Y stayed at 9, right? So that's our one equation. Our alpha in this case is 0.25. So that makes this a really nice example, because now I can put in 0.25 over 0.75, right?
Mm-hmm.
And hopefully, so is there anybody that has any questions about what I've just done? I'm trying to be explicit with parentheses. So there's no possibility for confusion.
So the 9 over 9, you got that from?
Well,
that would be from how much tequila is priced at?
Well, yeah, the price of tequila is the price of Y.
Oh yeah, okay, I get what you're saying. Yeah, because it's X1, so it's the change. It's the price of tacos when it was changed to $9, and then the price of tequila stayed the same.
Yep.
Okay.
Yeah. So our original price, so our original slope, if you ask, remember the prices determine the slope of the budget lines.
Mm-hmm.
The price of this original budget line, and I kind of don't want to, well, I'll just put over here. slope of right. Right. So does that make sense?
Yeah.
Right.
Yeah, it's just sometimes I forget a little bit because of questions on the previous slide. So I was like, wait a minute, how did the 9/9 come through? But I get it now.
Yeah, because this is just px over py.
Mm-hmm.
And again, you might be saying, oh, well, this is, a negative slope. And it's right. There is implicitly a negative in there, but I just dropped it because we don't need it to carry it around for anything, because our true condition is, the absolute value.
Yeah.
So, but yeah, so, and you can see the original slope is lower, right? It's like a fraction, and then it gets steeper and it becomes 1, right?
Mm-hmm.
And so again, we're looking for this tangency here. We have the same slope, and so this is our tangency condition.
Yeah.
And our real income constant condition becomes, well, utility of our original optimal consumption bundle we said is 10.25.
Mm-hmm.
And then we have XS raised to the 0.25 power times YS raised to the 0.75 power.
Mm-hmm.
Right?
Yeah.
And then you're in the exact same situation you were before. You got to do some algebra. So here, like I said, this example is really nice because it tends to the math tends to work out really easily, right? So we have basically YS, let's see if you follow me, over 3XS is equal to 1, right?
You put 3YS.
Oh, sorry. Okay.
Yeah, I get it, because you divided, you simplified both sides basically.
Yeah. So YS is equal to 3XS. Boom.
Yeah. And then now you just put that into the other equation.
Yep. There.
And so would you do these for all the problems? Like something similar like this?
If I want to get full points.
Yeah, I mean, in terms of like, it's kind of like, so when I look back at my notes, I can kind of be like, okay, I can kind of follow this for question 17 or question 16, like that.
I wouldn't spend this much time doing it if you couldn't do that. Like I don't know how else anybody here is going to solve these problems, but what I'm trying to teach you, and the reason why I say, let's say you find some magical calculator on the internet or something like that you can just put in some numbers and it'll give you out the solution. You put those in on Ignithium, right?
Mm-hmm.
Awesome for you. But guess what? Those points aren't going to stay, because as soon as I look at your blue book and I can't see how you got to the answer and I can't see that you understand these techniques, then that's why I say when you for most people, when they review the summary of their answers on Ignithium from the exam, you can calculate what in most cases is an upper bound to your score. If I look in your blue book as I'm calculating the grades at the end of the semester, and you don't justify your answers well, and in most cases, it'll mean doing something like this, then I'll take those points away. You know, if they like magically appear. And I say, and I say that with a little bit of flexibility, which means that, you know, if there's a good justification, if, you know, there's a little bit of, you know, algebra that's missing because people skip steps or whatever, like if you didn't do this line of algebra that I did, and you just went right to here, well, that's fine. Why would I care? Right. But if I don't see any justification or calculations and you just have an answer, then that's no good.
Yeah, it's like if I like didn't even do number like part 2 and then like number.
Yeah, I mean, yeah, honestly, a really good answer starts out with just something really simple like this, and then a couple of calculations, and then you give the answer. You know what I mean?
Yeah.
But because part of it's a time issue too. I understand that you don't have time to justify every single step because it's a timed exam. But you should be able to, you know, write the basic details and give, you know, as good a justification as necessary for your answer. Anyway, okay. So let's skip down to the next part, and here. So then, yeah, so, but our YS, right, we know is 3XS, right? So we just plug that in there and raised to the 0.75. And this is the reason why everybody likes the Cobb-Douglas so well, because it looks like, oh, this is going to be a pain because you have these fractional exponents. But guess what? It works out really nicely, because I don't know if you can see, but the algebra is not as hard as you might have initially guessed.
Yeah.
Because you can distribute the 0.75 power over both of the terms in the product in brackets. So you end up with, and I'll just do it this time so everybody can see. Times 3 to the 0.75 times XS again to the 0.75. And then these two terms, XS to the 0.75 and XS to the 0.25, are XS to the 1, right? So what you end up with is just, and again, this is why everybody likes Cobb-Douglas, because while there's algebra, it's not actually that difficult. You just need, and I guess I'll be, again, a little bit explicit so everybody can see what's in the numerator and denominator. You just need to use fractional exponents on your calculator to figure out what 3 raised to the 0.75 power is. And do you have your calculator with you?
Yeah.
So why don't you go ahead and calculate that for us, Sonika?
It's 2.27951.
Okay, is that 10.25 divided by 3 raised to the 0.75? Do you do the whole thing?
Sorry, no. It's 10. I just looked up 3 to the 0.75 power. So
okay,
I can do that.
Give us the whole thing.
It would be 4.39.
4.39. Okay, good. All right, so let's go back to Ignithium then. Stop sharing. and share, ignition, share. Okay. So 19. Okay. You got 4.39. This is
Yeah.
4.5. So I'm thinking there's a little bit
On
of,
mine, I have 4.49 and I just didn't round it all.
oh, 4.49. Yeah. Right. And then if we want to know if that's close enough, we just go 4.49.
Oh, sorry. Yeah, I got 4.4965. I've made a small error.
Yeah. Okay. But 4.49 is close enough
Mhm.
at 4.5. Yay. We solved number 19. Okay.
Yeah.
And then it says, what's the substitution effect on the purchase of tacos? This is the last one. Now, I want to also let you know that it has been a habit for me on the exam to ask people to also give the income effect. Remember how I like have a separate like answer or two? I ask you to draw something, and I might ask you to illustrate, for example, the income effect. So even though they're only asking about the substitution effect here, remember, that's only one part of our problem. We want substitution and income effect.
Yeah.
So if you have to illustrate them both, if I ask you to do that, and again, that's been a habit, then you want to know that, okay, I got the substitution effect. So it says, what's the substitution effect on the purchase of tacos? Well, we know we went from X0 to XS. And so let's see, before the price change, no, that's after the price change. How many tacos before the price change? So 5.43, okay. And then we go to 4.5. Okay. So how many tacos after the price change, before the price change? So yeah, if we go back, sharing, share screen, whiteboard, and go back to our illustration. So what we just found out, this, well, I guess I'll do it over here. We said X0 star is 5.43, and we calculated XS is 4.5, right? So the change, right, is the DXS, which D is for delta, or the change in, is going to be where we ended up, 4.5 minus 5.43. And that is, you have your calculator, Sonica? Are you with me?
Oh, sorry. I was muted this whole time.
Okay.
I got negative 0.03.
Do a calculation again.
Did I do something? Oh, I probably did something wrong. Sorry. 0.93, negative 0.93.
Yeah. Okay. And I don't know if you saw, but that's what we had on Ignithium. So if I stop share and I share again, and we go here, we'll go here. And sure enough, minus 0.93. See it?
Yeah.
Okay. So okay. So I just want to point out, and I did this again last time, but I'll do it one more time here.
Mhm.
Okay. So we're saying as we go from x0 to xs, we lose 0.93. That's our substitution effect. And
So when we say we lose 0.93, are we losing that much in utility?
no, remember it's the quantity of tacos.
Okay.
On the x-axis is the quantity of tacos.
Yeah.
Right.
Yeah, just trying to get, it's taking a little bit of time to register all of the different like X's, Y's, XS. So I'm just like, okay, let me just
Hey,
ask.
listen, I'm not saying it's easy.
Yeah, it's like it makes sense once you do the problem once with us.
Yeah.
So it makes much more sense now. But yeah.
Right. So anyway, I guess the main point is that the substitution here is the green arrow. So I'll say this is the I don't want to do that. They see these diagrams get pretty messy pretty quickly.
Yeah. Especially if it's all in one color.
Yeah. That's why I start to run out of colors. That's how you know things are getting bad.
Yeah, the whiteboard doesn't have that many options, which is upsetting. I actually changed to OneNote to take these notes because you can they give you the whole color wheel, so you can just pick any color you want.
Oh, that's nice.
Yeah, so it's been much easier to take notes and make these diagrams.
And this is the okay. So you can see the substitution income effect as illustrated here.
Mm-hmm.
And I suppose I'll just make a few kind of closing points. So and the language is subtle. So
Yeah.
I'll say this. Okay. So we said at the end, we want to say substitution effects are always negative.
Substitution effects are always negative.
Yeah. But what I wanted to point out is, like I said before, that does not mean that dxs is always less than 0. Okay.
Mm-hmm.
What it means is the substitution effect is, and I said this last time, but it's xs divided by dpx.
Yeah.
So in our case here, we already calculated the xs, but we didn't calculate the dpx. Well, we know it was a price increase. We went from a price of 7 to a price of 9. So, I'll just say here, dpx px is equal to the new price, px1, minus the original price, px0,
Yeah.
is 9 minus 7, which is equal to 2. So all this is saying is that if the substitution effect is always negative, then dxs, in our case, it's minus 0.93 divided by dpx, which is 2, that's going to be a negative number.
Mm-hmm.
Okay. This is always less than 0. And I'll be more explicit. This ratio, okay?
Yeah.
That's what it means for the substitution effect to be negative. Whenever you calculate dxs, as we did, it will have a sign that's opposite the sign in the change in the price of x.
Yeah.
So if we had a price decrease instead of a price increase, right, then we'd end up with a negative change in the price of x. A negative change is the price was 9 and it went down to 7, right? So that's a decrease of minus $2 would be the opposite case. If that happened, then when we calculated our dxs, it would be a positive number.
Mm-hmm.
And that's why this language in the problem of Ignithium is important, because if you carefully read the question, and it says, what is the substitution effect on the purchase of tacos? So it's not asking you to actually calculate the substitution effect. If it was going to have you calculate the substitution effect, it would have been that minus 0.93 divided by 2. That's the substitution effect. But what's the substitution effect on the purchase of tacos? How does the substitution effect influence the change in tacos? Well, it causes you to purchase, in this case, less, or 0.93 fewer tacos than before. And the other thing that I want to say in closing is, and I'll go back to this whiteboard, is that remember again that income effects can be positive or negative.
Mm-hmm.
Income effects can be positive or negative.
Yeah.
Depending on whether the good is normal or inferior.
Mm-hmm.
So in our example, again, what we're illustrating is the income effect on the purchase of tacos. So in this case, we're going to go from, if we're going to try to quantify, again, the income effect on the purchase of the tacos, we would do something like dx, call it I, right, for the income, which is going to be xs. We're starting at xs and we're ending up at x0. So I should do, or x1, sorry, x1 star minus s. Okay. So in this case, and again, you could, if you're going to actually calculate the income effect, it would be D, so that income effect, not on the purchases. This first one is the income effect on the purchases of tacos, right? But the income effect itself would be DXI divided by the change in income, right? But
Yeah.
to be clear, only if we went through the trouble, and this is why I did it before for another class, only if we went through the trouble to use the point slope form of this equation to find out, remember on the vertical intercept, we have the income associated with this line, right? 152 divided by 9. And for the new one, it's 152 divided by 9 also, right? But for this one, only if we found the level of income associated with this fictitious budget constraint that helps us identify the substitution effect,
Yeah.
would we be able to actually calculate the change in income here? And so I've never expected students to do that. It's, you know, if you wanted to do it on your own, or if you're curious about it, you could, but to actually calculate the income effect. But what I can tell you is pretty obvious, and that is that when I go from this line, the shifted budget line, right, back to the original new budget line, right, it's a parallel shift inward of the budget. That parallel shift inward is a decrease in income. So this delta income is going to be a negative number. Okay. This is going to be a negative number. And this DXI, right, going from XS to X1, well, you know that XS is bigger than X1. So the DXI is going to be negative. So you have negative over negative, which is positive.
Yeah.
Which means that X is a normal good. Okay, so the big picture is that even though we're going to have DXI be in this example, if we calculate it, it's going to be less than 0. It's still a normal good because the income effect, calculating it the way that we should, meaning as this ratio, the income effect is still going to be positive because the consumer has experienced a decrease in their income moving from this shifted budget line back to the new budget line. So it's going to be negative over negative, which is positive. It's a normal good. So I just wanted to let you all know that, because if you compute the income effects impact on the purchase of tacos, you're going to end up with a negative number. And I didn't want anybody to think that that meant that tacos were an inferior good, because they're not. The income effect is still positive.
Yeah.
Does that make sense? I know it's subtle, but you have to distinguish between the impact that the substitution effect and the impact that the income effect have on the purchases of the good we're analyzing, which is the tacos, right? What impacts those effects have on the purchases of tacos, and distinguish between that and the effects themselves, which are defined as these ratios.
Yeah.
And yeah, I mean, it's only if you do that, that you'll, so in the case of the substitution effect, it's a ratio. And in the case of the income effect, the ratio xi over d income. Okay. So I have said everything that I want to say about these last two. And I don't know if anybody has any questions, but we're just about out of time.
Mm-hmm.
Do you have any questions, Sonika?
No, I think this was helpful for sure. And so I took as many notes as I could.
Yeah, and you can go back and listen to it again. You know, you can, like I said, calculate. And what Ignithian's asking you to do is calculate the impact that the substitution effect, or if I ask you on the exam, I normally will ask about the impact that the income effect has on the change on the purchases of tacos, right? Mm-hmm. But that's just the numerator in the definition of the income effect or the substitution effect. And, you know, I guess if I was being really pushing things, I might ask you guys to actually verify that the income or the substitution effect was positive or negative in some way, you know, give some justification.
Yeah.
That would be kind of like a reach goal. You could do it in the case of the substitution effect because you have everything that you need to be able to actually calculate this ratio here. But for the income effect, you don't really have everything you need. At least I didn't show you how to do everything. On the effect. But anyway, but you guys have all the information. Okay. Well, have a wonderful election day. And I will stop sharing and I will